Greetings to everyone. Today we are diving into the world of JUnit in software engineering. JUnit, a renowned framework in the Java programming universe, is our main focus. It's a platform that's instrumental in testing, a critical aspect of software development. Testing ensures our code performs as expected, catching bugs early and solidifying our confidence in our software. We'll be exploring why JUnit is a go-to tool for this essential process. Now that we've set the stage, it's time to delve deeper into the workings of JUnit. JUnit isn't just a simple tool. It's a framework with several core components. Let's start with test cases. These are the building blocks of JUnit. A test case is a single unit of testing. It checks for a specific response to a particular input. Each test case is an independent entity testing one aspect of the software. It's like a detective, scouring for clues, searching for any discrepancies. Next, we have test suites. Picture a test suite as a container that holds related test cases. It's like a bookshelf where each book is a test case and the bookshelf itself is the test suite. Test suites are powerful because they allow us to organize our tests, run them together, and even nest them inside each other. Then we have test runners. These are the engines that drive our tests. A test runner takes a test case or suite, runs it, and generates a report. It's like the conductor of an orchestra, coordinating all the individual instruments to create a symphony of results. And finally, we have assertions. Assertions are the heart of JUnit. They're the statements that test the expected versus the actual results. You could think of an assertion as a judge, weighing the evidence and giving a verdict. If the expected and actual results match, the assertion passes and the test case is successful. If they don't match, the assertion fails, indicating a problem with the software. These components work together to create a powerful testing environment. Test cases provide the specifics. Test suites organize them, test runners execute them, and assertions evaluate the results. Each component plays its part, contributing to the overall effectiveness of the framework. So, why is this important? Well, understanding these components gives you the tools to write effective tests. It helps you to pinpoint issues, streamline your testing process, and ultimately improve the quality of your software. Understanding these components provides a solid foundation to leverage JUnit effectively. Now let's focus on the backbone of any JUnit test, the test cases. A JUnit test case is the smallest unit of testing. It checks for a specific response to a particular set of inputs. Essentially, it's a piece of code that asserts the truth of something. In the context of JUnit, we create these test cases to verify the correctness of our application's behavior. To create a test case in JUnit, we start by defining a public class. Then, we write a public method annotated with @test. This annotation tells JUnit that the public void method to which it is attached can be run as a test case. JUnit invokes each @test method it finds, and if any of them fail, it flags the test as unsuccessful. Now let's talk about the structure of a test case. A test case begins with a test fixture, an environment used to consistently test some aspect of the software. It includes the set of preconditions and expected outcomes. Then we have the test method, where we write the code to test the functionality. After that, we usually have a teardown method that cleans up the test environment. One important thing to keep in mind is the use of annotations in JUnit. We've already mentioned @test, but there are others. For instance, @before is used to prepare the test environment before executing the test. @after cleans up after the test. @before class and @after class are used when setting up and tearing down static test fixtures that can be used across multiple test cases. Remember, a well-written test case is concise, has a single purpose, and is independent of other test cases. It should be able to run in any order and still pass. In the world of software testing, writing good test cases is an art. It requires a deep understanding of the system being tested and a creative mindset to predict the various scenarios in which the system might behave unexpectedly. With a well-structured test case, you're well on your way to creating robust tests in JUnit. Assertions and test runners, two pillars that hold our JUnit tests together. Let's start with assertions. In the realm of JUnit, assertions are the heart of our tests. They are used to assert that something is true. In other words, they validate whether the actual outcome matches the expected outcome. Without assertions, we wouldn't have a way to check if our test passed or failed. They provide us the means to set the criteria for success or failure. We have a variety of assertions at our disposal in JUnit. For example, assert equals checks if two values are equal, assert true verifies if a condition is true, and assert not null confirms that an object isn't null. Each assertion serves a specific purpose and helps us to ensure our code behaves exactly as we expect. Now, let's turn our attention to test runners. If assertions are the heart of our tests, then test runners are the legs. They are what get our tests up and running. Test runners are responsible for setting up the test environment, running the test cases, and then tearing down the test environment after the tests have completed. In essence, they manage the life cycle of our test cases. JUnit provides several test runners, each designed to cater to different types of testing needs. For example, the block JUnit for class runner is the standard test runner which runs one test method at a time. On the other hand, parameterized is a special test runner designed to run the same test multiple times with different input parameters. So, in summary, assertions and test runners are fundamental to JUnit testing. Assertions allow us to set the criteria for our test cases and validate the test results. Test runners manage the execution of our test cases and ensure they run in an appropriate environment. Together, they make our JUnit tests both robust and reliable. Assertions and test runners make the process of testing in JUnit both efficient and accurate. JUnit isn't just an academic topic, it has real-world implications in software development. It's a powerful tool that software engineers utilize daily to maintain the quality of their code. In a world where software is becoming increasingly complex, JUnit serves as a safety net, catching bugs and errors before they become problematic. Think of it this way. JUnit is like the quality control team in a manufacturing plant, ensuring every product meets the required standards before it reaches the consumer. Similarly, JUnit scrutinizes every line of code, making sure it performs as expected. Moreover, JUnit makes debugging easier. Instead of combing through thousands of lines of code to find an error, JUnit can pinpoint the exact location of the bug. It's like having a roadmap to navigate through the intricate maze of software development. So, JUnit isn't just a tool, it's a critical aspect of successful software development. We've covered a lot of ground today, so let's take a moment to recap. We dove into the heart of JUnit, exploring its core components. We learned how to craft effective test cases, and we examined the role of assertions and test runners in the process. We also highlighted the significance of JUnit in real-world software development. Remember, mastering JUnit means mastering a crucial part of software testing. Keep exploring, keep learning, and see you in the next video.